I've posted some templates and files for this your next homework assignment, and I'm debating when I should make homework 5 due. So I'm thinking of the due date, and then when I figure out the due date, I will post that up. No, there's one homework after this that covers randomization tests. So this is. So normally I spend this day talking about simulation, and then I would do the homework, but I'm thinking I'll talk about it today so you can get started on the homework, and then Wednesday we'll spend talking about simulation, and maybe you'll be here for that. So this is how the homework assignment fits in with the greater scope of things. So as far as computational statistics goes, one way to answer, we might have questions related to probability that are difficult to answer analytically. And there is a way to answer these questions regarding monopoly in an analytic fashion, but it gets rather complicated. So what we can do is we can simulate what's going to happen. So I'm assuming most of you guys have played Monopoly, but then again, I recognize that it's kind of like this American board game traditional thing, like you get together as a family and you play Monopoly, and then at the end of it, everyone's angry with each other. And funny story about Monopoly is that the creator of Monopoly made the game with the intent of showing the evils of capitalism by showing that the only way to win the game is by bankrupting everybody and taking everybody's money away. But it turned out everybody likes being the role of the evil land baron and causing everyone to go bankrupt. And so I guess it's just ingrained somewhere in to be greedy. I don't know. Okay, but maybe not. But anyway. The way Monopoly works, this is, so forgive me for explaining how the game works, and you might already be familiar, but you start at go, and then you go around. There's 40 spaces along the board, and you roll dice, and you just move, right? So you roll 2 dice, so you can roll anywhere from 2 to 12, with 7 being most probable. And then and you move that many spaces. So if you roll, and then when you land somewhere, you have the opportunity to purchase that property. And when you own the property, then you can charge rent on people who land on your property in the future. And so what we're going to try to simulate is which spaces on the board are landed upon most frequently. Okay, well, this is the question that we're going to try to answer. We're not going to try to answer strategies regarding how to play Monopoly or what tactics or techniques or money management and trading or anything like that. All we're going to do is we're just going to say, there's a random element to this, which is rolling the dice. And if we roll the dice, which spaces on the board are going to be most frequently landed upon? This has actually been studied quite a bit. And the way most people answer or try to answer that question is through simulation, because trying to do all of the math for finding out which spaces get landed upon most frequently gets rather complicated. Okay? If there were no special rules, when you roll the dice and you keep moving around, then after, in the long run, all the spaces would be landed upon equally. Okay? However, we have little rules that complicate the matter. So for example, if you land on this spot that says go to jail, your token gets sent to the jail spot. Okay? And the jail spot actually has two areas. There's you are in jail, and then your token is locked in jail until certain criteria is met, which is like paying bail or you stay in jail too long and they kick you out. Or you can also land on the just visiting side, which is like if you are at go and you roll 10, then you landed on jail, but you are just visiting, you are not locked in. Other spaces such as the chance and community chest, has you draw a card from a deck. Okay, the deck will say things like, you won second place in a beauty prize, collect $10. Or it might say, move to the nearest railroad, or something of that nature, okay? And so, if you land on this chance space and it says move to the nearest railroad, you would move forward. You always move forward. You never go backwards. So the nearest railroad to this chance space is Pennsylvania Railroad. It's not Reading Railroad, because Pennsylvania is only 1, 2, 3, 4, 5, 6, 7, 8 spaces away. Reading Railroad is 38 spaces away, okay? Because there's 40 spaces around the board, or 39 spaces away or something. Okay, so don't go backwards. Although there is one card that says you move backwards, but and then there's other ones that say like move, go to Boardwalk, go to St. Charles Place, or go to this spot. Okay, so the decks add a little wrinkle of complexity in making the spots not equal. Okay, there's also rules, such as some cards will say go to jail, okay, and then you are in jail. Or if you land on this spot, you are sent to jail. Or if you roll doubles being two of the same numbers, so that would be 2 1s or 2 2s or 2 6s or something like that. If you roll doubles 3 times in a row, which doesn't happen often but does happen, you are also sent to jail for speeding, I guess. I don't know. Okay. So that's what happens. Okay. So that's kind of the rules in a nutshell. And so you'll download this RMD template, and I've put in kind of just some descriptions, and you can watch a video on how to play Monopoly, and the official rule book is here, which states that if you play the game by the rules, if you land on a spot and you don't want to buy it, it immediately goes up for auction, and it's not that you can just pass and say I don't want to buy this spot or things like that, and you're not allowed to lend people money and things like that, but whatever. Okay. So here's all of this stuff, and basically most of this, the instructions here are kind of talking about the rules. And what we are going to do is I'm going to have you run 1,000 simulations of a 2-player game that lasts 150 turns, okay? So this is technically over 600,000 dice rolls, which is 1,000 games times 150 turns times 2 players times 2 dice, plus additional rolls if you get doubles and things like that, okay? So it's a lot of things, and your job is to keep track of where the players land after we observe all of the rules, okay? And so you're going to build a table of all 40 spots, and every time somebody lands on one spot, you're going to increase kind of the tally or the counter for that spot. Okay, I've done a little bit of work for you in that I've created a data frame called Game Board, a data frame called Chance Deck, and a data frame called Community Deck. And you can kind of see what these things look like. So here we've got the 40 spaces on of the deck, and here are the the chance deck things. Okay, and I've arranged the deck so that all the so some of the cards move you spaces. Okay, so as far as the chance deck goes, the first 9 cards will move you someplace, and the other 6 do things like give you money, and so those do not move your token. Okay, so if you land on a chance space and you draw the card and it moves you someplace, you would move to that thing. But if you draw a chance card and it says pay poor tax of $15, then you stay on the chance space. Okay, right? I don't know what a poor tax is, but that sounds unfair. I think this really was like the commentary on capitalism, right? But and things like this, you know. And then the community chest deck. And as far as community chest goes, only the first two cards move you places. One advances you to go, and the other one sends you to jail. Okay. Everything else is about kind of collecting money or paying money or things like that. Okay. Okay, and so you're going to set up functions for all of these things. Okay, and so it says at first blush the task may seem overwhelming, but if you can break up the task into smaller, manageable parts, and I'm going to give you some code to kind of get you started. Okay, so first of all, you're going to want to start with just a simulation that moves pieces around the board and keeps track of this where they land, and I'm giving you some example code for this. Okay. So you're going to start with that, right? And if we understand how that part works, then we're off to a good start. And then it's just a matter of adding each set of rules one by one, right? So you're going to add complexity one at a time, okay? So add something. So all you have to do, the first one, the easiest rule to implement is just if this piece lands on the go to jail space, which is spot 31, I believe, you're going to have it move to the jail space, which I think is spot 10 or something, 11. Okay, so that's the first one. Okay, then you'll add some rules about how the pieces should move if you land on a chance card or a community chest card, things like that. If you roll doubles, you get to go again according to the rules. You get to move twice, and so you'll want to add that. And then the last thing is implementing the rules for the jail. That's the most complicated part, because when you're in jail, you have to stay in jail for 3 turns, and on the 3rd turn you get out. Technically, if you roll doubles while you're in jail, then you lucked out and you get out for free. There's some rules there. Okay, so read through the rules regarding jail, and you'll want to implement it that way. I've got all of these things about how it's going to be graded, and don't print out all of the output for all 1,000 games or things like that. Okay. Okay. So let me. Yes.
So let's say a token is moved to a player has to go to jail.
Yes.
And now it's in jail, and then the player on the next turn the player rolls doubles, so they get out.
Yes.
But are they allowed to roll again to make a move?
Now I have to consult the rules. Okay. But yeah, it's somewhere in here. Okay. So when in jail, the player has the option to pay a fee to get out, or he can choose. So a player cannot, if they roll doubles, he moves those spaces for free. It's in there. What there? Oh, even though he rolled doubles, he does not roll again. He takes his move out of jail and his turn ends. Okay. That's what it says. Okay, so the answer to your question, should be listed all out in the jail's rule thing. Okay. There's no choices. Everything's just following the rules. But yes, question.
And how about if a player is defeated?
Yeah, no, we're not doing winning or losing. Okay, we're not keeping track of money. We're not keeping track of property. We're not trying to implement some kind of strategy on buying or selling or trading. Okay, all we're doing is we're going to pretend, this is not 100% accurate, but we're going to pretend that games last exactly 150 turns and that they just keep moving around and around and around following the rules, whether or not they still have money or not. Okay? Yes?
So if we disregard the money portion, then do we disregard the option to pay to get out of jail?
Yes, we are going to implement what's considered a long stay strategy. Okay, there's different strategies regarding jail if you get into like competitive Monopoly world. And the general strategy is early on in the beginning of the game, while there's still properties to be purchased, you want to get out of jail as quickly as possible, and towards the end of the game, when all the properties have already been purchased, you want to stay in jail as long as possible because you don't have to pay any rent while you're in jail. Okay? We're going to just go with the long stay in jail strategy, which is not optimal in competitive gameplay, but we're not going to worry about that. Okay, we just have this general question of which spaces are landed upon most frequently, right? So if there's no rules and there's 40 spaces, then each space should be landed upon about 2.5% of the time each. Okay. All right. So anyway, let me just talk about how you can implement or do this. All right. And so I've created this file called Monopoly Getting Started Example. Okay, this is our code, and we'll go through this. Okay, so I have the data frames for the different things. Okay, and I'm creating a function called dice. Okay, these are random dice, and when you call dice, it's going to return a list of 3 things, which are the faces. In this case, we rolled a 2 and a 3. Is it doubles? It's false, and the amount you would move is 5. Okay. All right. So this is okay. So here's a dice function, and you can read through it. Basically, I'm just sampling 1 through 6, and we're taking 2 things with replacement, and so on and so forth. Okay. I'm also creating a function called for manual dice. Okay, now why do we want manual dice? Well, as you are working on your game, you might want to see if, like, you've implemented this thing on when it lands on chance, it's going to draw the card, and you want to make sure it works, right? If you are at the mercy of the random dice, you might roll and you'll be like, darn it, I didn't land on chance, and like you got to roll it like 100 times, and then finally you land on chance. Okay. So the manual dice allows you to provide it a vector of dice rolls, and you can kind of change that vector and say, look, our first roll, I'm gonna force you to roll 5-4 or something and land on the space, okay? Or maybe after you've implemented the doubles functionality where you've rolled doubles and it allows you to go again, and you want to make sure if I roll doubles 3 times in a row, it's gonna send me to jail, right? If you're doing the random dice, you've got to wait for 3 doubles to show up organically, which will take a while, right? So anyway, so this uses a reference class, okay, where you provide it a vector of rolls here, and then the position tells us kind of like where in this thing that we end up. So here I'm creating, we're going to create a new instance of our reference class, and this is going to be called set dice, and we're going to call our dice function, which will be from the set dice roll. Okay, and so you can see I said the dice we're going to roll is going to be 6, 4, 5, 3, 3, 5. Okay, and so if I do if I call the function dice here, it's going to call from this reference class. It's going to call the function roll, and so the first one will be 6, 4, and then the next one will be 5, 3, and then the next one will be 3, 5. Okay, so you can see how it continues, and the way it's keeping track of the movement with the manually set dice is it starts off at position kind of 0, and so it says 6, 4, and then it updates the position to 2, so that when it gets the next 2 dice, it's going to go 5, 3, and the position will get updated to 4. So it keeps track of its position in kind of this list of rolls to see what it's going to do next. Does that kind of make sense as far as the set dice go? No? It's basically, I'm giving it a list of what the dice rolls are going to be, okay? And you're basically telling your friend, starting at the first stop thing, pretend like the next two rolls, the next two numbers you see in this list, or this vector, are going to be your dice rolls, okay? And then it's as if you're going to pass this paper on to another person, okay? And you're going to, rather than like giving them an entirely new thing, you're going to give them the same list and just say, start at position 2 or position 3, okay? So that's what this is. We've got the rolls, and we're not going to update this roll vector continually. All we're going to do is we're just going to update the position from where to draw the next rolls. That's what we're doing with the reference class, okay? And so, so if we look at the function for roll, okay, for the methods in the reference class, the faces it's going to return is from the rolls vector, taking the position plus basically the next two, and then we update the position with by incrementing by 2. And then we have, is it doubles and what's the movement? And then the if verbose is an option to kind of print out all sorts of kind of diagnostic stuff to help us along the way. Okay, let me talk about the reference class that we're going to use for the players. Okay, so we're going to create a player reference class. And when you run your game, you're going to create 2 instances of the player reference class. You're going to create a player 1 and player 2. Okay, so if you think back to your object-oriented programming with reference classes, these are mutable, meaning that you can modify these things. And so all we're doing, the player reference class just has 2 values, okay? One is its position on the board, okay? And then the other is verbose, which means do we want to print out a bunch of diagnostic information, yes or no? So kind of when you're testing things out, you want to have verbose equal true, and when you don't want all of that information, you set verbose equal to false, okay? So here, this is all the only thing we're going to keep track of. And then we have 2 methods for the player, okay? One is move n spaces, and if it's verbose, it's going to print out all of this stuff. It's going to say player starts at this position, position 1 on the board. Player's going to move 5 spaces, so we're going to do position plus 5 is going to be our new position. And then if we go over 40, which means we've looped around past go, we've got to subtract off 40, okay? And then it will return player is now at this position. Okay, so that's what we have here. That's move n, and then I have another method called go to space n, which is useful for things like the chance card, which says, you draw it and it says go to boardwalk or go to jail or something like that. All you have to do is say, player's currently here, and then now we're going to go to space n, and player's now at here. Okay, so here is just a very basic reference class, and you'll probably want to add fields such as is the player, maybe you want to take notes on this, is the player in jail, okay, has the player rolled doubles, and if so, what count of doubles, right? Because it's on the third. If they roll doubles 3 times in a row, they're going to get sent to jail. If they're in jail, which turn are they in jail, right? Is it their first turn in jail, second turn in jail? Because on the third turn in jail, they're forced out of jail. Things like that. So these are just maybe a few other fields you want to add to your player reference class, and you might want to add some methods there. But here's just some basic ones to get us started. And I'm going to create 2 instances of player. So we've got player 1, which is going to be a new instance of our player reference class with starting at position 1, verbose is true, and player 2 is the same thing. So player 1 and player 2, we've got that. And if I ask what's player 1 is reference class object of player, the position is set to 1, and verbose is set to true. Okay. All right, now I'm going to create a reference class for tracking, okay? And all this is, it's going to be a vector of 40 values, and this is going to be the tally. So the first one will correspond to how many times the first spot go has been landed upon, and then the 40th value in our vector will be how many times the last spot on the boardwalk, has been landed upon. And so this is just a numeric vector, and then all we have to do, we have one method, increase count, which says take the tally in position n and add 1 to it and update tally there. Okay, so we'll create that. This is going to be our tracking reference class, and I'm going to create a new instance called space tracking, and we're going to start off with a vector of 40 zeros to show that all 40 spaces have been landed on 0 times. Okay, and then our most basic turn will be a function where we accept a player reference class object and a tracking reference class object. And we're going to say, we're going to look at role. We're going to create role, which is going to be which calls dice, or we can have dice verbose equal to true if we're not using the manual dice or something like that. Okay, and then here we're going to say all we're going to do is we're going to call the method moveN for the player reference class. Okay, and we're going to just move whatever the dice roll movement says. And then after we do that, we will increase the count in our tally at the player's position. Okay, and we will do this to the tracking class. Okay, and so because we're using reference classes, there's no take the output of this function and store it here. We're just saying player and apply this method. Okay, or run this method which updates the player itself. And for the tracking reference class, we're going to just say update the tracking reference class here. Okay, so increase n and move, or increase count and move n updates those reference classes inherently. Okay, so this is take turn, and that's a function. Is this okay as far as what this function is doing? Okay, and then we will just test this out. Okay, so here we're going to just do set seed 1, and we will say take turn for player 1, and we will update space tracking. Okay, so when I do this, it says we rolled a 6-2. Player is at 1, player moves 8, player now at 9. Okay, and then I'll do take turn player 2. Okay, it says we rolled a 5-4. You know what? I'm sorry. Let me just reset the dice over here, just so that this matches what we have here. Oh, okay. Well, because I have to redo my blank players. Okay, so got player 1, player 2, set seed 1. Okay, so here roll a 2-3. The player's now so player at 1. We move 5. The player's now at 6, and over here, player's at 1. We move 10. Player's now at 11. Okay, and then we can just check to see if our space tracking, because I've had all of these things, because these are reference classes, right? So everything is mutable. So I have to. This is the only frustrating thing about working with reference classes, is that everything alters everything. Okay, so I did those things, and then so now we can see the reference class for space tracking has been updated. We have a tally at spot 6 and a tally at spot 11. Okay, and if we ask what about player 1, player 1 is at spot 6. Okay, so here our simulation, just I will start by doing a new space tracking reference class, and here I'm going to simulate 100 games. And for each game, I'm going to create a new player, a new blank player, right? Player 1 and player 2. And then within the game, they do 150 turns, which is going to be, player 1 does this, and player 2 does this, so on and so forth. Okay, here I have verbose set to false, and all they're going to do is just take turn for player 1, take turn for player 2, and they just alternate 150 times. Okay, so one turn will be player 1 goes and player 2 goes. That's one turn. The next turn will be player 1 goes and player 2 goes, and so on and so forth. So here I've got a loop of 150 where player 1 and player 2 take turns 150 times. That completes one game. Then we will go back to the top and run that entire thing 100 times. Yes?
What is if player 1...
Verbose?
Yeah,
Okay, because verbose, remember in the player class, the verbose is either set to true or false, right? So if it's set to true, then it will say player 1's turn. Okay, if it's set to false, it won't print this out. Okay, so if I have in my creation, if I have this set to true, what we would see is a new game 1, and it'll go player 1, player 2, player 1 turn, player 2 turn, player 1 turn, player 2 turn, player 1 turn, player 2 turn, 150 times. Okay, and then it will say new game 2, and then it will go player 1 turn, player 2 turn, and that would be, painful to see. But I mean, if I crank this down to like 10 turns and only like 3 games simulated, we can see it. But
So just let us know.
yeah, here, you know what? Let's do that. We'll just do 4 games, and each game will last 5 turns, and I'll set verbose to true. Verbose will be set to true, and then let's set we'll have our verbose dice here. Okay, so we'll set seed 1 here, and then we'll just do this. Okay, so we're gonna play 4 games. Each game lasts only 5 turns. Okay, so it spits all of this out, and you can just kind of see this is what it has. Okay, so it says new game. All right, player 1 turn, rolled 2, 3, moves 5 spaces, now at 6. Player 2 turn, rolled 4, 6. Blah, blah, blah. Player 1 turn, it does this, and you can see how it updates each space. And then they do that 5 times, and then that's the end of game 1, okay? And then we do new game 2. All right, so this is the verbose output. This is like just 4 games of 5 turns each, and we can see it produces a lot of output. So we don't, please do not produce verbose output for 1,000 games of 150 turns. Your HTML file will be humongous, and it's not practical for the grader to have to go through that. So I'm going to set verbose to false. Okay, we're going to do that, and then we will set seed 1 here. Okay, so we'll do this. All right, so this is running through 150 games here, or 100 games. Okay, all right, so it's done after 100 games of 150 turns, and let's bind the tally and the game board together. All right, and let's just take a look at that, and so we can see all the spaces that this has landed on. Okay, because we haven't implemented any rules. And then we'll do this, and we'll add kind of a relative frequency. Okay, and then so without any rules, we can see indeed each space is landed upon about 2.5% of the time, which makes sense because you keep going around, every space gets landed upon about equally. So you start off here, and then you can just kind of see how many times do we roll the dice. There's 30,000 instances of where we've landed and counted this up, and so on and so forth. Okay. obviously you're going to have to implement some rules so that things don't get landed on equally, right? When you implement the rules, like go to jail will be 0. Like it's impossible to end your turn on the go to jail spot, because when you land on that spot, you are sent immediately to jail. So you will never increase the tally at the go to jail space. Okay, so that will be landed on very infrequently. The chance spaces will be also landed on very infrequently, because like half the time when you land on chance, you draw a card and it moves you somewhere else. So your turn doesn't end there, okay? So we'll do that. Okay, and then this is just to kind of show you how the manual dice works. So here we can set some manual dice. Our dice function will be set to this. We're going to have a blank player tracking thing, and then here we'll just do 20 turns of a game where we only have one player go. And you can see the implementation of the manual dice where I have the vectors 6, 4, 5, 3, 3, 5, so on and so forth, and you can see 6, 4, 5, 3, 3, 5, 6, 2, so on and so forth. So you can set your manual dice this way to make sure, like, you know, if I roll doubles, does my program recognize that I've rolled doubles and give me another turn, type of thing. Okay. Are there questions on this? Yes.
How does the go to jail spot ever have any land? Because like, don't you just
Yeah. So like, let's just look at the board. If you like, let's say you're right here, and you roll a 5. You go 1, 2, 3, 4, 5. Okay. So I think this is position 31. Okay. So if you're at position 26, you roll a 5, and you do take turn. It's going to say, okay, player at 25 or 26 rolled 5. Okay, moves 5. Player now at 31. And then before you say increase tally, you're going to say player at 31. Okay, player gets moved to 11, which is the jail space, right? And then you say player is now in jail. And then finally, after all of that, then you say, okay, time to increase the tally put at spot 11, jail. Okay, and then so the jail count goes up by 1. So you basically you move, and then you increase the tally there, right? So if you roll doubles, you'll move, you'll increase the tally, and then you get to go again, and you move and you increase the tally there. Okay. But yeah, you would, if you go to jail, you would move there, but you get moved again to the jail spot, and you only increase the tally at the jail. Okay. If you land on chance, you don't increase the chance tally. You land on chance, you move, you follow the chance instructions, and if it moves you someplace, you move to that new place, increase the tally there. The only time you'd increase the chance tally is if you draw a card that doesn't move you. Okay, and all of this should be explained in the rules. Or is there another question? No.
Because I said if you land on the go to jail,
Yeah.
then you don't increase the tally, you increase the tally of 11, so it stays 11, because that's being go to jail.
Correct.
So go to jail will never have any.
Yeah, so at the end of the game, go to jail will have a tally of 0. Yeah. So that, like, at the end of your game, if you have anything other than 0 at go to jail, you know you did something wrong. Okay, and that will be like one of my criteria for grading. It will be go to jail should have a count of 0 for the tally, because nobody can end their turn on the go to jail spot. Yes?
How does the frequency probability impact when you try to set that out?
Uh-huh. Yes. Because there's 40 spaces, and if I haven't implemented any rules and I just keep moving around, every space gets about approximately equal, and so 100% divided by 40 is about 2.5%. Okay? Okay, so we'll start here, and then, you know, this should be an interesting project that that you can try out here, okay? Okay. All right, we'll see you guys maybe on Wednesday. So, and if not, have a great Thanksgiving weekend.